Hello guys, my name is Make Fortune and I'm your geography tutor. So today I'd like to welcome you to our geography lesson as we look upon our CAPS curriculum ATP for geography. For week 1 and week 2 we are going to be dealing with Mid-Latitude Cyclone, but obviously because we are in online extra lesson, grade 12 extra lesson academy, we're gonna hit this by one video so that the rest of the 2 weeks will be dealing with other important stuff like giving activities and making sure that everyone is on track. Okay, so in grade 11 we learned about the global air circulation. We know that at 0 degrees we have the equator, at 30 degrees we have the subtropical high, at 60 degrees we have the subtropical low pressure, at 90 degrees we have the polar high pressure. So what I want us to know is that we're gonna be dealing with cyclones that happen between these pressure belts. Okay? The cyclones that happen between these pressure belts. Between all of these pressure belts in the northern hemisphere. We know that above the equator we have the northern hemisphere and below the equator we have the southern hemisphere. So now what we're gonna do is that we're gonna be focusing on mid-latitude cyclone. So I won't really touch the global air circulation because we all know that in grade 11 we learned about the global air circulation. If you don't know, if you still have problems with the global air circulation, please make sure to specify in the group so that we may do a revision on global air circulation. So right now I'm just gonna focus on how a low pressure forms. Now we know that a low pressure forms when a cold air mass meets a warm air mass. Now when they meet, the warm air will rise because of the cold air that undercuts. Because cold air is dense, it does not coat for being uplifted. It always subsides. So warm air, because it is light, it is always uplifted. So cold air will now undercut warm air and the warm air will begin to rise, and hence an area of low pressure will be created. As I said, I repeat again, that for a low pressure to form, we have to have warm air, and what? And cold air meeting. So let's say this is our warm air and this is our cold air. Now the warm air will rise. Why? Because the cold air will undercut it. And once it is undercut, the warm air will be isolated from the ground. On the ground, we'll only have cold air. Then in the atmosphere, we'll have what? Warm air. Hence, an area of low pressure will be created with the what? A clockwise air circulation in the southern hemisphere. Okay? Now we're gonna move on our today's topic, which is a mid-latitude cyclone. Now what is a mid-latitude cyclone? A mid-latitude cyclone, it's a low pressure system that affects areas between 30 to 60 degrees north and south of the equator, with a clockwise rotation of air in the southern hemisphere and an anti-clockwise in the northern hemisphere. Now I want us to understand this, that the low pressure system spins clockwise in the southern hemisphere, but however in the northern hemisphere low pressures go what? Anti-clockwise. So meaning that because high pressures are anti-clockwise in the southern hemisphere, meaning that in the northern hemisphere high pressure cells will move what? In a clockwise direction. So remember, a mid-latitude cyclone is a what? It's a low pressure system that affects areas between 30 to 60 degrees north and south of the equator, with a clockwise rotation of air in the southern hemisphere and an anti-clockwise rotation of air in the northern hemisphere. So now the mid-latitude cyclone affects these areas 30 to 60 degrees, these areas only. Now, why does the mid-latitude cyclone affect these areas of 30 to 60 degrees? Why these areas? Because the mid-latitude cyclone, let's wait, I'll come there, why it forms at the areas between 30 to 60 degrees. Let us continue. I wanted to explain something that I'm going to explain further forward. So now, I want us also to look at the concept Coriolis force. We have the concept Coriolis force. Now, Coriolis force, we know that Coriolis force deflects wind to the left of its course. Where? Now, you can see that it deflects the wind in the southern hemisphere to the left of its course, and in the northern hemisphere it reflects wind to the what? To the right of its course. Now, we know that our Coriolis force helps us with what? With the rotation of what? The rotation of a cyclone, or the rotation of air movement, right? I hope you understand. Remember, where you don't understand, you pause the video, rewind, and return to where you'll be able to understand. Now we're going to focus on the area of development. Now, the area of development is located in the middle or temperate latitudes, and those middle or temperate latitudes are between latitudes of 30 to 60 degrees south, north and south of the equator, which is what? Which is the subtropical high pressure and the subtropical low pressure. Now, here is why they form between 30 to 60 degrees. Why mid-latitude cyclone form between 30 to 60 degrees north and south of the equator? It is because at 60 degrees, we have what we call the polar front, where warm westerlies and cold easterlies do what? Meet. I want to show you something. Yeah. At this area of what? Of 60 degrees, we have warm easterlies and cold easterlies, warm westerlies and cold easterlies meeting at this area. Now they begin to create a boundary here, because these two warm air masses, they don't have the same temperature, the same density. Remember, cold air is dense and is what? It is cold. But however, warm air is what? It's light and what? And humid. Now, this is what I want us to understand, that there is a boundary at 60 degrees called the polar front, whereby the warm westerlies and the cold easterlies meet. And when they meet, that is how a mid-latitude cyclone develops. Remember, when cold air and warm air, meets, when cold air and warm air meets, the warm air will rise. Why? Because the cold air will do what? Will undercut. Hence, an area of low pressure is what? Is formed at the interior or at the surface. Remember, a low pressure forms when a warm air and cold air meets, and the cold air will undercut the warm air, and the warm air will be lifted high. Okay? Remember, you pause the video, you copy the notes, and pause it and continue with the video, so that you may be able to be on track. Okay? Where you don't understand, remember to inquire in the group, for we have a group whereby you must inquire. Okay? Now, what are the conditions required for the development? Now, as I've said, this is the same point at this one. As I've said, that we need what? A cold polar easterlies and warm westerlies to meet. Remember, a low pressure is formed when warm air and cold air meet. When they converge, then the warm air will be uplifted and the cold air will begin to be what? Will begin to undercut. Now, the mid-latitude cyclone occurs throughout the year, but mainly affects South Africa in winter. Why does it affect South Africa in winter? The northward migration of the ITCZ, with it the migration of the high pressure cells, results in the low pressure system moving over the southern part of South Africa. Forgive me of this spelling here, guys. So this one, for you to come and understand the reason why mid-latitude cyclone affects South Africa in winter, it will need us to be able to touch the anticyclones, the high pressure systems, and the ITCZ, which is the third topic that we're going to be covering this time in geography, in climate and weather. So this one, for you to understand this one, let's just wait for us to touch anticyclones, then you'll be able to understand it. Now let's go to characteristics. Now, a mid-latitude cyclone consists of what? A clockwise movement of air. There is a clockwise movement of air in the mid-latitude cyclone. Remember, a mid-latitude cyclone, it's a low pressure system. And here, remember, we are referring to the southern hemisphere because we are in South Africa and we live in the southern hemisphere. And remember, a low pressure in the southern hemisphere spins what? Clockwise. Okay? Another characteristic is that a mid-latitude cyclone must have the presence of what? Of a cold front. Now, for you to understand what is a cold front, we'll have to wait for us to touch the sketches. So the sketches, we are going to touch them as we go down. The sketches on the hypnotic weather map, so that you can see what is a cold front. Another characteristic is a what? A cold sector. Again, we have to go to the sketch for you to understand what is a cold sector. The presence of what? Of a warm front. Also, again, we have to understand what? The sketch also, for you to understand what is what? A warm front. Now, the mid-latitude cyclone moves from west to east as it is driven by the or steered by the westerlies. Now, they will ask you a question in geography, that what is the general direction of a mid-latitude cyclone? And you will say it moves from what? From west to east. If you don't want to say west to east, you can say eastwards. Eastwards. The examiner will still award you marks for that. Then they will come again and ask you, why does it move in that direction? Then you will say it because it is driven or steered by what? By the westerlies. Okay, I hope we understand. Now, as I've said, it affects the western sides of the continent in the middle latitudes. Here we're referring to the places of the areas of 30 to 60 degrees north and south of the equator. Now, the diameter is between 1,500 and 3,000 kilometers. Now, this mid-latitude cyclone travels at a speed of 50 to 60 kilometers per hour. The mid-latitude cyclone has a lifespan of 4 to 14 days. Now, when we say 4 to 14 days, we are meaning on land. On land, it has it can survive for 4 to 14 days. Okay, I forgot this one. It occurs throughout the year but affects South Africa mainly in winter. And the part of South Africa which it affects mostly, it's Cape Town, right? Now, another characteristic is that they usually occur in families of 2 or more, known as what? A family of depression. Now, they'll ask you in a multiple choice question or a matching type question, what is a family of depression? What is a family of cyclone known as? What do we call a family of cyclone? Or a family of cyclone is known as? Then you'll have to pick where you see family of depression or whereby you see depression. Okay? Now, let us move to the what? To the stages of development. This is where it is very interesting and you need to know. So for you to know the stages of development, you'll have to put this down. You'll have to be able to make a mnemonic, IDMO. Now, what does this I stand for? This I stands for what? Initial stage. The D stands for what? Development stage. The M stands for what? Mature stage. The O stands for what? Occlusion stage. Now, if you begin to cram this, or maybe you begin to familiarize yourself with this mnemonic, you'll be able to know the stages with your head. IDMO. Remember, initial, development, mature, and occlusion. Now, let's continue with the what? The initial stage. Now, with the initial stage, the polar front is stationary. As we can see, this 60-degree belt here is the polar front. It is stationary. It is not moving. It is stationary. Now, the warm westerly and cold easterly winds blow in opposite direction along the polar front. As you can see, the cold air is moving to an east direction, and the warm air is moving to a west direction. Why are they moving in opposite direction along the polar front? Because the different air masses do not have the same temperature, therefore they do not mix. Remember, this is cold and dense air. Remember, dense means heavy. Dense means heavy. This is cold and dense air, and this is warm and light air. So the temperature, the density or weight is not the same. So henceforth, these two cannot mix. Henceforth, friction develops between the two air masses. We are done with initial stage. Remember, you pause the video, you copy the sketch, copy the notes of initial stage so that you may not be left behind. Now let's continue to the second stage. We have the development stage. Now what happens in the development stage? In the development stage, it says a wave develops in the upper front. Now remember, initially we had a line here of 60 degrees, which is the polar front. Now in the upper front, remember this is up, this is low, this is the lower side, and this is the upper side. Now in the upper side here, we have a wave which develops. Now when this wave develops, when this wave develops in the upper front, a small mass of warm air extends into the cold air and rises. As you can see, this wave is causing what? It's causing, remember this air was moving straight. The warm air was moving straight. Now when a wave develops, this warm air begins to extend into what? Into the cold air. And now remember, I said whenever cold air meets warm air, the warm air will be uplifted. Because why? It is light and humid. So therefore the cold air will undercut it, and an area of low pressure will develop. So as I've said, a small mass of warm air extends into the cold air and rises. This rising air causes a low pressure in the center. As we can see, a low pressure resulted in the center. Why? Because a small mass of warm air extended into the cold air. This is the part of the cold air. But the warm air mass, because of this wave that occurs here, the warm air extended into the cold air, and immediately when it extends into the cold air, they begin to converge, and warm air does what? It rises, and when it rises, an area of low pressure does what? Develops. We are done with what? The development stage. Remember to pause the video, to copy the sketch, copy the notes. Where you don't understand, you rewind the video, re-listen, so that you can be able to understand. Now we come to the third stage, which is mature stage. Mature stage, as I've told you that I'm going to explain about the warm sector, cold front, and warm front. Now this thing here, we call it the warm front, the cold front. How do we see the cold front? We will see the cold front on the synoptic weather map as something like this, with pyramids, some sort of pyramid symbols or triangular symbols or sharp point symbols. They represent what? The cold front. Now these semicircles, they represent what? The warm front. Now this whole part, the part up to here, let me remove this. This part, actually the whole of this, it is the warm front. Why is it a warm front? Because we have warm air inside of it. Now this part, we call it the cold sector. As you can see, cold sector, warm sector here. This whole part is the warm sector. Why is the cold sector? Why is it this cold sector? Because we have cold air masses in it. We can see here we have cold air, and here we have what? Cool air. Okay, we also have the warm front. Here's the warm front, and here's what? The cold front. Now let's continue. The low pressure intensifies. As you can see, the isobars are beginning to gain what? To gain momentum. It moves into the westerly wind belt away from the polar front. Remember I said the mid-latitude cyclone, on the characteristics, it is steered by what? By the westerlies. It moves from what? From west to east, because it is driven and or steered by what? By the westerlies, or pushed by the westerlies. Now the reason is because we name wind from the direction it comes from. Now the westerlies come from the west, but they are moving towards what? Towards the east. So now the mid-latitude cyclone will move away from the polar front, enter into what? The westerly wind belt, so that the westerlies may push it to the what? To the east. That is why we say it moves from what? From west to east. Are we understanding each other? I hope so. Now we have a well-developed cold and warm sector are present. As I've said, this whole part here, it is what? It is the warm sector, and this whole part here, it is what? The cold sector. They are well developed. Now the cold dense air moves faster and forces the light humid less dense warm air in the warm sector to rise. Remember, cold air is dense, it's heavy. Now when it is heavy, remember the cold front behind it, it is approached, this cold front, it is being approached or pushed by what? By cold air. Now this cold air, because it is heavy, it pushes the cold front to become more faster than what? Than the warm front. That is why the warm sector is smaller than what? Than the cold sector. Because you see this cold front here, it used to be here, somewhere here. But because there is cold air behind it, this cold air pushed it to this direction, and next time it will be pushed to some sort, to this direction, to this place. Okay, I hope you understand. Now we say the cold sector becomes larger than the cold sector becomes larger than the warm sector. Let's cancel this cold here. The cold sector becomes larger than the warm sector as the cold air moves and lifts the warm air. Remember I said when cold air and warm air meets, the warm air begins to be what? To be uplifted, and the cold air does what? That undercuts the warm air, and an area of low pressure develops. So this cold air, because it moves faster, it isolates the warm air from the ground. So on the ground we will have more cold air, and wherever we have the cold air, more cold air, it means we have what? A cold sector. So hence the cold sector becomes larger than what? Than the warm sector. Remember, where you don't understand, you pause the video, you rewind, or maybe you can, because we have a group, you can enter the chat group, ask videos, so that what? You can understand more further. This was the mature stage. Now let's move to occlusion stage. Remember to copy the sketch, because on the hypnotic method map you will see something like this, and they will ask you which stage is this. Then you'll have to answer that it is what? It is a mature stage. Now let's move to occlusion stage. Now occlusion stage is the final stage of what? Of the mid-latitude cyclone. Now for you to see that this cyclone is on an occlusion stage, the first step you must look is at the apex of the cyclone. At the apex of the cyclone, you will see mixed symbols of what? Cold front and warm front. As you can see, we have the sharp point or pyramid or triangular symbol of cold front, and the semicircle symbol of what? Of warm front. Okay. Now let's see how do we describe the occlusion stage? Now this occlusion stage, I'm gonna tell you something. It mainly comes in a paragraph of 8 lines, or the 2 times 2 question, or the 3 times 2 question. They will ask you and say, describe the stage which in approximately a paragraph of 8 lines, describe the stage which led to the development of what? Of the cold occlusion stage, cold occlusion, and what? Warm occlusion. We have 2 types of occlusion. We have warm occlusion, we have the warm occlusion stage, and what? The cold occlusion stage. So we have the cold front occlusion and the warm front occlusion. So, but here it's occlusion stage as general. So they're gonna ask you, describe this occlusion stage itself, which led to the development of a cold front occlusion or a warm front occlusion. So it means you're gonna describe this one. So now, what do we say here? We say the warm sector continues to narrow. Remember, the cold front is faster because this cold air behind it is pushing it to overtake what? To overtake the warm front. Okay? Hence, the cold front overtakes the warm front. Therefore, cold air undercuts warm air. Remember, behind the cold front we have cold air, and ahead of the cold front we have what? We have warm air. And hence, when this cold front moves from this position to this position, it does what? The cold air behind the cold front will begin to what? To undercut the warm air ahead of the cold front. Then the warm air becomes isolated from the ground. This is called what? Occlusion. Now, what are we referring to when we are saying the warm air is isolated from the ground? Remember, in occlusion, we say what? We say, I mean, in mid-latitude cyclone or in geography, we say when cold air meets with warm air will be uplifted, and cold air will be what? Will begin to undercut what? The warm air. And over the ground, we will be left with so much cold air. We'll be left with only cold air. All the warm air will be in the atmosphere. But here on the ground, we'll only have what? Cold air. On the ground, we'll have cold air. But on the atmosphere, we'll have what? Warm air. That is why we say what? When the warm air then becomes isolated. When after the cold air undercuts the warm air then becomes isolated from the ground because it is uplifted to the atmosphere, and on the ground we were only left with cold air. Okay, I hope we understood. Remember, when you have inquiries or questions, you come to the group, you ask any question, we will attend to you. Now we have the cold front occlusion, the first occlusion stage, the first of the 2 types of occlusions, the cold front occlusion. Now, sometimes they will ask you to draw this sketch, or sometimes they'll give you the hypnotic weather map, and they'll say, tell us the type of stage. But mainly they'll want you to draw this sketch. Now this sketch, you'll have to draw it like this. So I'm gonna explain these sketches. Now, for you to see it on the hypnotic weather map, for you to see that this is a cold front occlusion, you will have to see first what? On the apex. Remember, on the apex we have mixed symbols. We have mixed what? Symbols. For you to see that this is on the hypnotic weather map. Remember this one, the cross shape represents the hypnotic weather map. For you to see that this hypnotic weather map chart will be representing a mid-latitude cyclone in cold front occlusion, what you must first see is that the last symbol, this one, the last symbol on the apex. When I'm meaning the apex, I'm referring to this new tail here, showing that the cold front and the warm front were what? Were combining. This last symbol here, which if it shows you a cold front symbol, just know that this is a cold front occlusion. Remember this last symbol on the apex. If it shows you a cold front symbol, it is a cold front occlusion. But if it shows you a warm front symbol, this last one, if it shows you a warm front symbol, it means it's a warm front occlusion. But if it shows you the cold front symbol, it is a cold front occlusion. Okay, make sure to copy down these sketches. So now, remember, they will come and ask you, what does the symbol of the cold front represent on the end of the apex? Then you will say it represents that the cold front undercut what? The warm front. I hope you heard me clearly. So now let's move. Let's describe the process. Air ahead of the cold front is warmer than the air behind. Remember, this is also a paragraph of 8 lines. They will say, tell us the process that resulted in the cold front occlusion, or tell us the cold front occlusion that resulted in heavy rainfall of the mid-latitude cyclone. So air ahead of the cold front is warmer than the air behind. Let's go back to the sketch. You see, we have warm air ahead of what? The cold front. And behind the cold front, we have what? Cold air. This causes the cold air behind the cold front to undercut what? The warm air ahead of it. Remember, I said whenever cold air meets with warm air, the cold air will undercut the warm air, and the warm air will be lifted up into what? Into the atmosphere. Now, resulting in the warm air being rapidly uplifted along the steep pressure gradient of what? Of the cold front. Remember, it says what? Being rapidly uplifted. Don't forget to write this. This is very important. Along what? The steep pressure gradient. This is also important for you to include. Resulting in the warm air being rapidly uplifted along the steep pressure gradient of the cold front. Okay, I want to show you something. On this sketch, on this 3D sketch, you can see that this is the cold front. This blue line represents the cold front, and this red line represents what? The warm front. So when they give you a sketch and they ask you what kind of occlusion is this, you must see the cold front touching what? The ground, to show that it is undercutting what? The warm front. Now let's not focus on that. Look at this cold front. You can see that it is creating a steep slope. It is creating a steep slope. Now this steep slope, remember, because we are dealing with air, it means we are dealing with pressure. Now when we are dealing with slope, it means we are dealing with gradient. So now this, because this is a steep slope, we now refer to it as a steep pressure gradient. Okay, the cold front creates a steep slope for what? For the warm air to be what? To be to be uplifted what? Rapidly. That is why we say the warm air, it results in the warm air being rapidly uplifted along what? Along the steep pressure gradient of the what? Of the cold front. Now the rising air, this is the last point, cools, condenses, and forms cumulonimbus cloud. Now let me give you a hint before I continue. Do not wrong the spelling of cumulonimbus cloud, because if you wrong cumulonimbus, they give you wrong. They need the right spelling. So this rising air cools, condenses, and forms cumulonimbus cloud, which results in what? Frontal rainfall. If you don't want to say frontal, you can say heavy rainfall. Now, as we can see along the cold front, we have what? Cumulonimbus clouds which have developed over along the cold front, which result in what? In heavy rainfall. Make sure to pause the video, copy the sketches, also to pause the video, to copy the notes, so that you may not be left what? Behind. Okay, now let's continue to the second and last part of the occlusion stage, which is the warm front occlusion. Now, how do we identify the warm front occlusion? We identify it on a sketch when the warm front is undercutting what? The cold front. You can see the cold front now, it is above the what? The warm front. Now, how does this happen? I'm going to explain it to you. Now, on the cyclotic weather map, how are we going to see it? The last symbol on the apex will be the semicircle of what? Of the warm front. That is when you must know that this is a warm front what? Occlusion. You will know that this one is a what? It's a warm front what? Occlusion. When at the apex, the last symbol at the apex, when it shows a semicircle of the warm front, you will know that this is a warm front occlusion. Now let's go to the process. Air ahead of the warm front is cooler than the air behind it. Let me go back to that sketch of this one, because on that one I did not finish it. Remember, we say what? Air ahead of what? Of the warm front. This is the warm front. We are saying air ahead of the warm front is colder. Remember, we have cool air ahead of the warm front, and behind the warm front we have what? Warm air. So we say air ahead of the cold front, of the warm front, I mean, is colder than the warm air behind it. Okay? This results in the air ahead of the warm front undercutting the warm air behind. Remember, the air ahead of the cold front, it is a cold what? Cool air. It's cool air. Now, cool air is cold. Now, I said whenever cold air meets with what? Warm air, the cold air will always undercut and the warm air will always be uplifted. That is why we say this results in the air ahead of the warm front undercutting the warm air what? Behind it, leading to the warm air rising along the gentle pressure gradient of the warm front. Now let's go to the 3D sketch. As we can see, our warm front, it is portraying a what? A gentle slope. As you can see, this is gentle. It is portraying a gentle slope rather than the steep slope of what? Of the cold front. Now, when the air will begin to rise gently, remember, when warm air rises rapidly, it will result in cumulonimbus clouds, which bring about heavy rainfall. But when it rises gently, it will bring about nimbostratus clouds, which bring soft, soaking rainfall. Now, this rising air then cools, condenses, and forms nimbostratus clouds, resulting in rainfall. As you can see, our nimbostratus cloud, then it will begin to result in what? In soft, soaking rainfall. Now we are done with what? With our mid-latitude cyclone. Let us go to the impacts of the mid-latitude cyclone. Now, when coming to the impacts of the mid-latitude cyclone, firstly, we are going to focus on the weather conditions associated with what? With the passing of the cold front on Cape Town. Weather conditions associated with the passing of a cold front over Cape Town. Now, how are we going to say this? We're going to describe this, because also this one, it comes in a paragraph of 8 lines, 2 times 2 question, which is 4 marks, 3 times 2 question, which is 6 marks. Okay? Yes. So let me change the color to red. Now, the first point that I'm going to give to you, it says air pressure increases. Why does air pressure increase? Because warm air is replaced by the cold air behind what? The cold front. Remember, warm air is associated with less pressure, because whenever we have warm air, we have low pressure. But whenever we have cold air, we have what? High air pressure. So now the air pressure decreases because warm air is replaced by the cold air behind the cold front. Second point, wind direction changes from west to south, which is backing. We call it wind backing. In the southern hemisphere, when wind changes its direction, we call it wind backing. But in the northern hemisphere, when wind changes its direction, we call it wind veering. In the northern hemisphere, we call it veering. We call it veering. But in the southern hemisphere, we call it backing. Okay? I hope you understand. Now, the wind direction changes from west to south. Why? Because the local air joins the clockwise circulation of the mid-latitude cyclone. Third point, temperature decreases. We know that whenever we have warm air, the temperature will increase because warm temperatures are high temperatures, but cold temperatures are low temperature. But cold temperatures cold air is associated with what? Cold temperatures. Now, why do temperatures decrease? Because warm air is replaced by the cold air behind what? The cold front. Remember, the cold air behind the cold front will undercut the warm air ahead of the cold front, which will be uplifted into the atmosphere, and it will be isolated from the ground. On the ground will be only remaining with cold air. Another point, cloud cover increases because warm air rises over the approaching cold front, cools, condenses to form cloud. Remember, cloud cover, we are speaking about how the atmosphere is covered by what? By the clouds. Now, when cloud cover increases, why do cloud cover increases? Remember, I said the warm air will be undercut by the cold air, and it will be rapidly uplifted along the steep pressure gradient of the warm front, of the cold front, I mean. And when it is uplifted there, it will begin to do what? To rise. It will cool down, it will condense, and it will form what? Clouds. That is another point. Then we say cloud type is cumulonimbus what? Cloud. Remember, when warm air is uplifted rapidly on a steep pressure gradient, it will result in clouds, which result in heavy rainfall. And those clouds, we call them cumulonimbus clouds. But however, when it rises over a gentle pressure gradient, it will result in nimbostratus clouds, which result in what? Gentle or soft soaking rainfall. Okay? Cloud type is cumulonimbus cloud. Why? Because the steep pressure gradient, because the steep pressure gradient associated with the cold front forces the warm air to rise rapidly. Now, we are going to the type of rainfall. The last point of weather conditions associated with what? Weather conditions associated with what? With the cold front, with the passing of the cold front over the interior or over Cape Town. Now, the rainfall type is what? Is heavy rainfall because of the strong convection and cumulonimbus cloud. Okay? What do I mean when I mean strong convection? So much warm air is being uplifted from the ground into what? Into the atmosphere. Okay? Remember cumulonimbus clouds, we described how they form. Now let us go to the impacts of mid-latitude cyclones. We're going to start with the impacts on what? On humans. The positive impacts. Now, the question of impacts of mid-latitude cyclone will come in two ways. Either in the 3 times 2 question, or will come in an approximately 8-line paragraphs. So they will not say in human, they might say describe the positive impacts of mid-latitude cyclone on humans. Okay? Yes, on humans or on farmers. If not on farmers, on the physical natural environment, on animals, It depends on the examiner on what context he would like to refer to. Sorry about this, guys. So now, winter rainfall determines the type of crops that are cultivated. Remember, the type of rainfall we get in winter will help us to be able to know what kind of crops are being cultivated or are being plowed or are being farmed in winter. Remember, there are certain crops that we farm in winter. For perhaps say cabbage. Let's say cabbage. Cabbage is being farmed in every season of the year. But there are some certain types of crops which are farmed in winter. Okay. Now, the Mid-Latitude cyclone increases food security. Why does it increase food security? Because the Mid-Latitude cyclone brings about much needed water. It brings water, and when it brings water, farmers are able to have water to be able to irrigate their crops. And when they are able to irrigate their crops, they will be able to produce more and more and more farming food or more farm produce. And when our farms begin to produce large amounts of food, it means even we as the people in the country of South Africa, we are able to get or to have access to enough sufficient healthy nutritious food. Now, the rain replenish water in dams. What is to replenish? To replenish is that the rainfall now begins to fill up the water in our dams. And when our dams have more water, it means us as people, we have more water to use for domestic use. We have more water to use on our gardens. We have more water to do more water sports, all kinds of things. Okay? Another point, snow in the mountains replenish water when it melts. We know that when snow melts, it when you speak about things such as sublimation, I don't want to go to physics because I'm not a physician. I do not do physical science. But when we speak about things such as sublimation, condensation, those kinds of things. So now, or freeze, or melting. Let's just keep it simple. Let's just keep it simple, guys. I'm sorry about this again. My app crashed out. Which one is impacts? Yeah, I'm sorry about that. My app crashed out again. Sorry about this. Remember, I promised you that in February we'll be having the right equipment for you guys to be able to study, to be able to watch our videos very clearly. Now, the low temperatures. Let me increase this top. Sorry guys about this. Let me change the color. Now, low temperatures for fruit farming. Remember, when the cold front reaches the land, it reaches the land with its cold air. Remember, behind the cold front we have cold air. Now, that cold air, when it reaches the land, it isolates the warm air away from the ground. Warm air will only dominate in the atmosphere because it is rapidly uplifted. But on the ground, we'll only be left with what? With cold air. And when we are left with cold air, we'll be able to do what? Fruit farming. Remember, there are those fruits that are only ripe in winter. I mean, they can be able to be ripe in winter. What are those kind of fruits? Citrus fruits. Citrus. Now, when we refer to citrus fruits, we are referring to mainly things like oranges. We're referring to oranges, naches, tangerines, those kinds of fruits. Those are citrus fruits, okay? Now, let's go to the negative impacts of Mid-Latitude cyclone on humans. Now, the first point or the first negative point of Mid-Latitude cyclones on humans is that flooding can result in the loss of lives of people. Now, remember, when there are floods, people can die from floods. People can be drowned in floods. Remember, floods also destroys houses, destroys everything. Now you might find that the flood, it floods at night, and we are all in our house, giving ourselves shelter, because we all shelter ourselves within our houses. So then the flood ends up coming into the house and will be all killed and drowned inside our houses. As I said, it destroys homes because of because of the heavy winds that it is associated with. Remember, when we are referring to the weather conditions associated with the cold front, we said air pressure increases. Now, when air pressure increases, it means that when air pressure increases, it means that wind speeds have increased. Okay? Wind speed, we know that when we have high winds, roofs can be carried away by those winds. There are people who are living in shacks, who are living in shanty houses, who are living in house made of cheap material. So those houses can be swept away or can be carried away by the wind. Loss of agricultural land. Okay, remember, this mid-latitude cyclone is associated with heavy rainfall. Now, remember, most places that we farm on the floodplains, which is adjacent to the river, which is next to the river. So now, when more water has flooded the floodplains, it means we have limited amount of space to farm on. Risk of food insecurity. Now, remember, these points, make sure to elaborate them, because I'm just giving you points so that you will have to elaborate them further, because you cannot write them like this. Risk of food insecurity. Now, when we have much rainfall, rainfall can destroy our crops at the farm. So when more crops are destroyed, it means more food is destroyed, and hence people have less access to food. And when there is less access to food, it means not all the people will be catered for. Poor visibility and traffic accidents due to heavy rainfall. We all know the story of Makgoba's Kloof. At Makgoba's Kloof, we know that whenever there is heavy rainfall here in Tzaneen or in other places, wherever there is rainfall, we have what we call mist. And when there is mist, we have poor visibility. And whenever you cannot see what is happening around you, because there is so much mist. In your car, you might get an accident because you can't see the car that is in front of you. So you might end up being involved in an accident. And accidents can be fatal. Someone can die from accidents. Now, mountain passes are closed because there is no mass of movement. Okay, mountain passes, we are mostly speaking about those roads that are found on mountains. If it snows on mountains, those roads will be blocked, so there won't be enough road for people to pass with their cars or to travel to other places. Now we are done with all the impacts of people on humans. Now let us go to the impacts on the physical natural environment, the positive ones. It brings much needed moisture to the soil. Now remember, the rainfall, when there is so much rain, the ground also does what? Begins to infiltrate more water. It begins to absorb. Remember, infiltration, we're speaking about the absorption of water. Now the ground begins to infiltrate more water or to absorb more water, and it becomes what? It becomes to be moist. And when it becomes moist, the soil is now good for farming or good to be used, mainly specifically for farming. The revival of biodiversity, ecosystem, and habitat. We all know that the natural plants, the mountains, the animals, they thrive when there is rainfall. When there is enough supply of rainfall, we know that they thrive, especially plants. They thrive after rainfall. We know that plants thrive. Water availability for wildlife. So now in the jungle, in the forest, or in the wilderness, when there is much rainfall, the wildlife, such as lions, hyenas, giraffes, elephants, all those kinds of animals, they are able to have enough water for them to live. Okay. Water availability for growth of natural vegetation. Okay, natural vegetation, we're speaking about trees, plants such as plants such as trees, grass, all kinds of natural vegetation that we can see around us. They begin to grow because there is much water. Water allows for more grazing land. Now, this is good. You know why? Because grazing land is where our animals, mainly farmers or people who own livestock, they know that when there is enough rainfall, there is more grazing land, their animals will be able to grow, especially cows, sheep, goats, chickens. The chickens don't graze, obviously, but cows, goats, and sheep, when there is enough rainfall, more grass grows, and meaning that they will have what? More grazing land. Fill up by infiltration. Fill up by infiltration, natural aquifers or groundwater. What are natural aquifers? Natural aquifers are those stones that are found beneath the surface of the earth, whereby you will see a certain households calling for a borehole truck to come and dig a borehole. Now, when they dig that borehole, their aim is to find this stone so that they can penetrate through this stone and have access to the water that is inside that stone. Then that stone, we call it what? An aquifer. So now when there is enough rainfall, those stones begin to have more water inside of them so that the family's borehole may never run what? Dry. Fill up of river via surface runoff. Surface runoff, we know that we are speaking about the rapid movement of water on the surface. Now, when there is so much water on the surface, it begins to move into our rivers, and our rivers begin to have what? More water. If there were rivers that were starting to lose water and about to dry up, the water runs into the river, and the river begins to what? To be rejuvenated. Okay? Guys, allow me to do something because I can see that I'm going to be disturbed. So I have to put do not disturb because we are in a lesson. So the physical, natural environment, we also have the negative impacts. What are the negative impacts? Low-lying areas are flooded. There are people who have houses near the rivers. There are places, let's forget people because we are referring to the physical natural environment. There are places which are near the river, and those places, they are low-lying areas. Those places are easily filled up, are easily flooded by water. And there are animals, some animals live near the river. And why? Those animals that live there, they will never have a place to live at because why? Those areas are flooded. Soil erosion increases. We know that after heavy rainfall, soil erosion occurs. Destruction of biodiversity, habitat, or ecosystems. We know that sometimes rain can destroy plants, can destroy natural vegetation. It can destroy or kill animals. It can uproot trees, do all kinds of things. Remember, Mid-Latitude cyclone is also associated with what? Heavy winds. Those heavy winds can uproot natural vegetation. Damage to natural vegetation, still the same thing. Loss of wildlife, still the same thing. Wildlife will begin to die. Increases salinity in rivers. Salinity, when we say increase in salinity, we are mainly speaking that our waters will have less quality. It means the water will have less quality, and henceforth the animals that live in water can actually die from this. So saturation of soil. Mainly soil will have so much water that it won't be of quality. Rock falls or mass movements on steep slopes. So when we speak about rock falls and mass movements, we are speaking about, let's say this is a mountain. This is a mountain. Now let's say there are rocks here, which this mountain has rocks here. Now, when there is heavy rainfall, heavy rainfall can cause these rocks to fall on the ground. And you find that there are animals living on the ground. Now when these stones begin to crash, when there is a rock fall or mass movements on steep slopes, it begins to endanger the animals or the life that is down slope. Okay, now let's go to the strategies to reduce the impact of mid-latitude cyclone. Remember, wherever you did not understand, you pause the video, you rewind and ask questions into the group. Now the first strategy to reduce the impact of mid-latitude cyclone is that monitoring the development of a mid-latitude cyclone. We must monitor it. How? Through satellite. We have satellites. So if we use satellites to monitor the development, we'll be able to know which areas will be affected by mid-latitude cyclone, so that we can begin to evacuate people there, so that they can be at safe places. As you can see, the second point says what? People and animals should be evacuated to high-lying areas. High-lying areas, we're speaking about the mountainous places or the high hills, whereby people will be safe from floods. People should shelter to seek protection against what? Cold weather conditions. Remember, mid-latitude cyclone, when it reaches the land, the cold front will begin to undercut the warm front, and only cold air will dwell on the ground. So people must seek places to be. They must be in their houses so that they can be warm. Warm from what? From these cold weather conditions. Provision of food and water to displaced people and animals. Remember, those people that we evacuate from those areas that are going to be affected from the mid-latitude cyclone, they will need food, they will need water. So those animals also, they will need food and water. So we must supply them with what? Food and water, so that they can continue to be what? To be healthy and to be able to live. Provision of healthcare. To who? To the people who might be injured, who might get injured from the places which are affected by mid-latitude cyclone. Effective early warning systems or communication infrastructure to warn the people. Now, when we have this, we are able to warn people that the mid-latitude cyclone is approaching your area, so that those people can begin to prepare to do what? To evacuate. Plant winter crops that can resist the cold. Now, as I've spoken before, that we have citrus fruits, which are able to be planted in winter because they can resist the cold. Thank you. This is Mahagama Bitela. I thank you for being wonderful, for attending this geography lesson. We have touched mid-latitude cyclone, and I hope you'll continue to watch our videos going forward. Thank you. Peace.